Welcome to Chem 110's Experiment 3, Calorimetry. This will be one of 3 videos, so a video for each section. Hopefully you've looked through the procedure so you have an idea of what's going on. But we'll run through it real quick anyway, so hopefully the data makes a decent amount of sense. All right, we are using a calorimeter. In the actual lab we use styrofoam cups, but I don't seem to have any around the house. We have thermometers for measuring the temperatures, and of course we got our analytical balance for knowing what the masses of the water and the unknowns are going to be. All right, in the lab we measure out the empty calorimeter, we weigh it, we get some water going on the Bunsen burner for an eventual source of hot water, and then we transfer just regular room temperature water to the calorimeter and weigh that. So getting on with the data sheet here, first thing to do is recognize that some of the formatting got messed up in one of our revisions here. So these little lines over here don't really mean anything. They're supposed to be the continuations of stuff over here. And it looks like the only one that's really bad. Okay, so let's weigh our calorimeter. We find out that it weighs 7.50 grams. When we add roughly 60 mils of water to it, we get 62.51 grams. The original temperature of our room temperature water, it's 22 degrees Celsius. And the hot water, which is boiling water, should be close to 100, but never really is in our labs for a couple of reasons. So we'll just say that was 97.5 degrees Celsius. All right, at this point we add the hot water to the cool water, and we just keep track of the temperature for a few seconds as the thermometer catches up with what's actually gone on. So, you know, a couple of seconds in, maybe it was 48 degrees Celsius. And 15 seconds and on, let's just say our final temperature was 51.2 degrees Celsius. After we've recorded those temperatures, we take the mixture of waters back into the balance room and find out that we had 98.53 grams. All right, so with this information, we should be able to see both how much energy the hot water lost and also how much the cool water gained. And we'll do that on the calculation page. So starting off with the calculations, our mass of the cool water is going to be the a difference between the calorimeter with water, which we said was 62.51 grams, minus the empty calorimeter, which was 7.5 grams. And that's going to give me, 55.01 grams. All right, the mass of the hot water, similar thing. We just don't want to double subtract the calorimeter. So this would be that final mass, the 53 grams minus the 62.51, and that difference is 36.02 grams. Temperature change for the cool water. Here it's appropriate to have a general equation. Temperature change, we like to write that as delta T, and our deltas are always going to be the finals minus the initials. So simply put, that's going to be my final 51.2 degrees minus the original cool water was 22 degrees. What would we say, 22.0? And that difference is 29.2. Temperature change for the hot water, same thing, delta T equals T final minus T initial. It's the same final temperature, but the initial temperature is now referring to the initial temperature of the hot water, which for us was 97.5. And that difference is formally a negative 46.3 degrees. And the only thing the negative tells us is which direction the energy was going, or in this case, if something cooled off, we have a negative temperature. If it heated up, we had a positive temperature. But we're going to bury that negative sign in the choice of words gained and lost down below. All right, our energy gained, our favorite equation from calorimetry is that energy is equal to mass times specific heat times delta T. And since we're talking about the cool water here, we're talking about the mass of the cool water. Oops, sorry, got ahead of myself here. Back to the temperatures, positive, negative, we're not going to worry about that. That's just telling us that something cooled off or heated up. And we're going to ignore those when we use the words gained and lost. All right, so back to the energy gained by cool water, we need to make sure that our data here is specific to the cool water. So the mass of the cool water was 55.01 grams. The specific heat of water is 4.18 joules per gram degree Celsius. And our change in temperature for the cool water was 29.2 degrees. Units cancel, my grams are out, my degrees Celsius are out, and I'm left with joules. Numerically, punch that in the calculator and get 6713. Looks like we have 3 sig figs, so we might call this one 6710 joules. All right, energy lost by the hot water, same start. Energy is mass times specific heat times delta T. And in this case, we use the mass of the hot water and the delta T of the hot water. So the mass of the hot water, 36.02 grams. My specific heat is still 4.18 joules per gram degree Celsius. And my delta T in this case was 46.3 degrees. Again, units cancel. And I'm left with joules. And for this one, it looks like I get 6967 joules. Again, if I round that to 3 sig figs, it's at 6970. All right, we'll give some directions on doing the calculation the second time around. In part 1 of the lab, what we would hope to see is that the energy lost by the hot water works out to be about the same as the energy gained by the cool water. That would tell us that the calorimeter is working pretty well. This difference here of 200 joules on 7,000 represents what, about a 3% difference, so that's actually pretty good, but it's all made up. If we do calculations for the second trial, there'd be no real connection between the first trial and the second trial. That's going to depend on how much water we had, etc. But what we should see is an agreement of gain versus loss, both in trial 1 and in trial 2. All right, that's it for part 1. We'll do the other 2 parts and then maybe wrap that up with a discussion of the whole experiment.